I would like to revisit this slide for just a second. I didn't spend much time on it in class, and I wanted to make sure that everybody understood what we were looking at. So the data, which we know how to put into stat edit, and we can use our graphing feature to make a histogram, and it shows it to us here. So uniform, it all changed the same, 1, 2, 3, 4, 5, so it all kind of changed the same. Bimodal, you notice there's a mode here and a mode here, so that's why bimodal. And then the last one, normal, with the perfect symmetric peak. So I just wanted you to understand no mode, bimodal, and then perfect one mode, and then everything's perfect, centered right around it. And we talked about all of that. So going on to, this is where we ended, which is 3.2b. 3.2b. Let me see if I can't focus that a little better. I believe that did it. I think this is where I stopped. And what we have here is, in a group of 80 men, how many should be between 64 and 76? Well, that's 2 standard deviations away, which is 95%. But then we have to say 95% times 80, and that tells us how many men fall in that category. So that would be 76 men. And what percentage of men should be shorter than 73 inches? So that 73 is here, and that's everything beyond here. So if we added up all of our percentages, that would be 34 plus 34 plus 13.5 plus 13.5 plus 2.35 plus 0.15. Too many plus signs. I get 97.5%. But my paper says 84%. So let me do that again. So that would be, this one's 13.5, this one's 2.35, and this one's 0.15. So if I take 100 and subtract 13.5 minus 2.35 minus 0.15, there's 84%. 84% of men should be shorter than 73 inches. What is the usual range? The usual range was within 2 standard deviations, and that would be 64 to 76%. The next one, scores on a stats test is a normal distribution with a mean of 80. So the mean goes in the middle, and standard deviation of 5. So we go up by 5. 3 standard deviations, down by 5, 3 standard deviations. This is 34, 13.5, 2.35, and 0.15. And this is the mean line. So the notation is N and 80 and standard deviation 5. What percent of people, I don't know why that keeps getting blurry. Sorry. So if you couldn't see what I was doing before, the mean was in the middle, standard deviation by 5, and then I put my percentages. What percent of people should have an IQ between 75 and 85? That's one standard deviation, so that would be 68%. And you can think of that within one standard deviation. In a group of 30 students, how many students scored? The difference between these two is this says what percent, and this says how many. This one wants a percentage. This one wants you to take the percentage and find out the percentage of students. So between 70 and 90, that's 2 standard deviations, and within 2 standard deviations is 95% of 30 students. So 0.95 times 30 equals 28.5. But we can't have 28.5, so we'll say 28 students. What percent of students scored above 90? So that's these two, which is 2.35 and 0.15. So that's 2.5%. What is the usual range of scores? That's within 2 standard deviations. And so 1, 2, 70, 1, 2, 70 to 90 was the scores.